Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
For those of you watching at home, thanks for the extra 5-minute delay. It's my pleasure today to introduce Reid Holmes. We here in the HIP group at MSR are huge Reid fans because he's been doing the user-centered design of software development tools, for longer than we've even existed as a group. And today he's going to tell us about how reuse ought to be done.
That's right. Thanks, Rob, and thanks for coming to my talk. As Rob mentioned, I've been doing my grad studies for a long time. I'm a software engineering researcher from the University of Calgary. And one thing that really is really key to the work that I do is that I think writing software is a lot harder. Writing and maintaining software is a lot harder than it actually needs to be. And I think one of the main reasons for this is that over time, systems continue to scale out in size and complexity. But developers' primary way of interacting with these systems is still through what essentially is a souped-up text editor. Okay, and they always have the same view. It's a text editor, and it's built into some sort of development environment quite often. And these IDEs provide a wide range of somewhat general functionality. And one way that I really think is important and key to helping developers improve their effectiveness is by providing them a more rich set of tools that address specific tasks that they undertake in their day-to-day activities. So today I want to talk about one of these tasks in particular, and that's of pragmatic reuse. So we're going to look at pragmatic reuse in some depth. And I just want to start off with a concrete scenario of what exactly a pragmatic reuse task is. So we have this system called AltiGPX, and AltiGPX visualizes GPS track points. So there's a user of AltiGPX. He goes out for a hike, and at the end of the day, he's wondering, I'm sweating a lot. I've just had this great hike, and I want to know how my elevation has changed. How has it actually changed? And AltiGPX shows me this nice XY plane view, the plan view from above, but I really want to see a profile. So he goes and he files a bug on AltiGPX saying, AltiGPX should be able to visualize these track points. And he even gives a little screenshot. He's like, I want it to look like this, giving him the developer some idea of what he wants. And the developer of AltiGPX gets this bug report. He says, well, I don't know anything about making profile views. But you know what? This sounds similar to something I've seen before. So he thinks to the Azerius system. Now, Azerius is a peer-to-peer BitTorrent client. It has very little to do with GPS functionality at all. But the developer says, see, look, this looks kind of like this guy's screenshot he wants. It goes up, it goes down. It has this nice legend on the side where we can say how high they are. It even has this nice red bar for the 5-minute moving average, which is nice for averaging out noise. And I'm a GPS developer, so I know that there's a little bit of noise in GPS tracks. So having this line is quite useful. So really what I want to do is I want to figure out how can I extract this functionality from Azerius. So I want to come up with a plan. How can I reuse this piece of functionality? And then what I really want to do is I want to enact this plan. So I want to take this functionality and plug it into AltiGPX. And this obviously sounds like kind of a bad idea because this is a peer-to-peer real-time BitTorrent client and this is a static GPS system. But if you actually go undertake this task and you do it, you end up with something that looks just like this. And that looks pretty good. It has shading, it has good colors, has the red line. And this task can take less than half an hour. You end up reusing 450 lines of code. So this scenario is something we're going to come back to a few times in the rest of this talk. But this is really what I mean by a pragmatic reuse task. So the Azerius developer certainly didn't intend their visual component to be reused. And he's making a BitTorrent client, so he's not interested in making his this visual component be reusable. But at the same time, the AltiGPX developer was still able to use this in a concrete way to help him save time and leverage this, a really well-tested and well-developed feature within his own system. So how would a developer actually go about performing this task manually? What would a developer actually do? Well, this is somewhat unfortunate, but Rawson and Carroll describe this approach as debugging something into existence. So the first thing you're going to do is you're going to search through Azerius and say what code is involved. And it turns out that this scaled graphic class is the speed graphic class, is very important in this task. So the first thing you're going to do is you're going to copy the speed graphic class into your development environment. Say, okay, there we go. Now we're started. And we see from the right-hand side, there's a lot of red here. So there's a lot of compilation errors that the developer has to deal with. And we talked to one of our industrial developers, and he said he likened this to a paramedic. So what you're trying to do is you're trying to staunch the flow of blood. You're trying to go through and fix these compilation errors and get this red to disappear, you know. The unfortunate thing about this is after your first copy, you're looking at 76 compilation errors. And 76 compilation errors, that's okay. I mean, that's a lot, but you can manage it. So the developer says, well, I'm going to go to the first one and try and resolve it. So at the top here, we can see that speed graphic extends scaled graphic. So obviously, this is another class I'm going to need. So he's going to just go off and copy that as well. So he copies over scaled graphic, and now it kind of stinks. He's up to 111 compilation errors, right? But he's like, oh, well, we're going to keep at this. This. I still want to do this. I do not want to write this functionality myself. I mean, that Azirius graph looks pretty good. So he says, oh, background graphic. Let's copy that next. So he does the copy. And now we're up to 152 errors. Okay, like this is not making my day. You know, I wanted this to be an easy morning. I want to knock off for lunch and have this functionality be finished. And this just isn't working out. Okay, I'm just going to give up. Like, seriously, this is going to get worse before it gets any better. And I don't actually know if it's going to work in the long run anyway. So this type of approach really makes it easy for a developer to get discouraged, because your first attempt and the way that you perform these tasks manually now, like the way that a developer would go out to set out to do this, is to copy the code. You're going to copy it over, and it's really easy to get discouraged and give up quickly. And this is a problem because in this case, in this Azirius case, I'm here to tell you that it's actually a good reuse task. It saves you a lot of time. You could do it in half an hour. You're reusing 450 lines of code. Like a fast developer might be able to write 450 lines of code in half an hour, but it's not going to be very good in the first place, right? So it's actually a good reuse task, and you don't really want developers to be giving up on good reuse tasks. One thing that's also really important to note is, like, as you're going through and you're copying these classes, eventually you're going to stop copying classes. You're going to start fixing compilation errors. And as you make these edits, this is a highly manual process. And you might realize after editing for half an hour that some decision you made half an hour ago was a bad one. So you have to go back and you have to undo it, or you have to step back out of these changes you made and change your mind. And that's a very, very manual process. And maybe the worst possible outcome that could happen here, even worse than giving up on a good task, is to go and copy all this code and work on it for a day or two and then find one specific error that you can't resolve. So you say, wait a minute, this task will never work. What am I thinking? You know, I'm going to give up. And then you just lost 2 days development time on something that was a complete waste of time. And this is a scenario we want to avoid more than anything else. So this scenario is, we're going to be talking, I'm going to come back to this Azirius example a few times throughout this talk, but this is just an overview of how a developer would perform this task manually today. So the talk is going to look something like this. We're going to talk up front about pragmatic reuse, give a little bit of background on the reuse spectrum itself, talk a little bit about planning. So planning is, I think, a key component to actually making these tasks work out. So instead of the developer just going through willy-nilly and working on this code, trying to hack something together, we actually make a coherent plan of what they're trying to do. We're going to look at enacting these plans, then finally a quick look at the contributions of what this work really can tell us about reuse. And then I want to end with a little look at some future directions that I'm interested in and a quick summary. So we're just going to start with a bit of background here. So when people talk about reuse, they're talking about black box reuse. I mean, in general, you think about reuse, you're thinking back to McElroy in 1968 at the first ICSI, and he's talking about a Sears Roebuck catalog of components. So this whole commercial off-the-shelf components idea of using these components and you glue them together, and it's magic. You have this great system that comes out of it. It's perfect. Why don't we all do it that way? And it turns out there's two really big, well, there's economic and technical reasons for this not being the case, that you do it all the time. And two really big technical issues are that of architectural mismatch and library scaling problems. So it's really hard to get components to just glue together nicely. It just doesn't work. There's some sort of core mismatch issue that makes it so this component is not going to work with this component. And if you try to make it so that all these components do work together, you end up with a scaling problem where you have many copies of the same components so that they do fit together effectively. And from an economics point of view, if you think of an industrial point of view, creating reusable software is a very expensive proposition. So Gaffney has found it to be 1.5 times more expensive to create something reusable than just creating something itself. And making up your loss in this extra cost is actually very difficult to do, right? Because a business most businesses aren't in the business of making reusable software. They're in the business of making software in the first place, right? So it doesn't add much to the bottom line that it is reusable. You can't go to your customers and say, hey, look, we made this reusable. Your customers are going to say, I don't care. You're my bank. I want to withdraw and do debits. I don't care if it's reusable. It doesn't help me at all, right? So explaining away that extra 1.5 times cost and investment is very hard to do. I just want to quickly note that there have been a lot of different approaches that have looked at trying to resolve these architectural mismatch issues and various problems with black box reuse. But what's ultimately important and what I want to focus on today is that developers really do still perform a lot of white box reuse tasks. So even though this is a nice ideal to look up to, these white box reuse tasks and pragmatic reuse being one of them is an important subset that we need to consider. So in 1992, Kruger did this survey of reuse approaches. And he came up with 7 main kinds of reuse, and pragmatic reuse was one of them. So he actually didn't call it pragmatic reuse at the time. He called it code scavenging. And code scavenging has sort of a rat-like feral quality to it that's sort of unfortunate. But the reason he used this sort of negative term is that there are some really key problems with this code scavenging type approach. And the first that he outlined is that the ad hoc nature of these tasks makes it really easy to embark on bad tasks or give up on good ones. So the fact that these are the highly manual tasks that you're going through and you don't have a good overview of what you're doing, unlike black box approaches that are very upfront. You plan it out, you have these components, you do a lot of upfront planning, it's very explicit, is a negative. And the second problem, he said, is just that adapting these pieces of code that weren't planned to be, weren't designed for use in the first place is very expensive. And these are 2 things that we talked about in the last slide. We just talked about the manual approaches. And these are things that you can conceptually just understand yourself very easily. And one thing that we've found through the literature in the past few years is that there's been a lot of studies that have shown that developers really are performing these white box reuse tasks. So one paper I want to point to in particular is this study at NASA. So NASA as an organization has spent a lot of money and even has groups dedicated to creating reusable software and training people to write their software in a reusable way. And you can understand that NASA, you can see why they'd be interested in this, right? They have different spacecraft, they want to share components, and it's a domain where reuse can really have some tangible benefits from them. But in this study, Selby found that 47% of all the reuse at NASA was actually white box. So even with all of this effort that they put into having good black box reuse approaches, 47% of it still ended up being white box in nature. So given just these various endorsements of white box reuse approaches, we really wanted to go to developers and say, well, do you perform these yourself? Like the literature clearly points to the fact that developers do, but they don't say much about how they perform these tasks and what's important for these developers when they perform these tasks. So we really wanted to go and say to some developers, tell us about your tasks, your pragmatic reuse tasks. Tell us about how you perform them, and let's see if we can help you out at all. So we went to 12 different industrial developers, and the number is not terribly high, but they were in 6 different organizations, and each of these organizations was actually from a different domain. So that we had a very broad spectrum of developers that we talked to. And these developers, we gave them a survey, and we talked to them individually and just recorded conversations with them. And we came out with these 3 key findings. And the first was that developers are performing pragmatic reuse tasks. And obviously, this one wasn't terribly shocking to us because all this other literature said that this was the case. But it was nice for us to just have this confirmation. At the time we gave the survey, 11 of the 12 developers reported recently performing a pragmatic reuse task. So 11 out of 12 isn't too bad. So the second point is really the most interesting thing that came out of all these studies, and that is understanding the scope of these dependencies. The dependencies of a piece of code that you want to reuse is absolutely essential. So what they said is, when I'm looking at a pragmatic reuse task, what I want to do is I want to figure out what code is involved, and then really the key point for me is to understand how is this code coupled with the rest of the system that it was built into. Because this code wasn't designed to be reusable, and it certainly wasn't designed, wasn't modularized to be reusable. I mean, it may be, but certainly not on purpose. And so the developer wants to see, well, can I actually extract this code from the system? How expensive is this going to be? How hard is it going to be? And this measure, whatever measure they would use, because they would just be looking at this informally, would help them decide whether or not to pursue this reuse task. And the last point that these developers told us is that for the task they were working on at the time that they completed this survey for them, they said that portions of their current development task could be met by pragmatically reusing code from other code that they had access to. So these guys were all in industrial environments, and they all had very large bodies of code at their disposal. So they had a lot of code that they could reuse if they wanted to. They didn't have legal issues with reusing this code. It was their own. They owned it. It was just a matter of actually doing it. So it was nice to hear that these developers actually felt that they could be performing these reuse tasks even more, but for various reasons they weren't. And I guess I should just mention up front, if anyone has any questions during, feel free to interrupt. I meant to say that at the beginning, but yes. So pragmatic reuse approaches have some unique challenges. So we have an existing system like this, and the developer system is something like this. Now it's not going to have this big explicit hole in it, but it makes PowerPointing easier here. So what the developer wants to do when they have this code, this existing system, they want to go through and say, what parts of it are relevant to me? So they're going to go and they're going to look at one method and see how this method calls this other method, and they're going to decide this is sort of the informal boundary of the code that I want to reuse. Because they need to define this boundary in some way. They don't want to reuse the whole system within their own system just for one little piece of functionality. So they want to identify what's actually relevant. Then what they need to do is they need to extract the code from the existing system and integrate it into their own. So when you see the extracted code here, we have a whole bunch of structural dependencies that are laying around. And these are method calls and field references and inheritance relationships that aren't fulfilled. So the developer says, I'm going to reuse this base class, but not its superclass. So that dangling dependency has to be managed in some way. Or I'm going to reuse this class, but not these three other classes that this method is calling. And you have to manage these manually. And this is really where these compilation errors arise from.
Sorry, just to make sure I'm following, so in your Aserius scenario,
yes,
the green boxes here are really just that one class that you cared about?
No, so yeah, so in the Aserius example, so the green, sure, one box is going to represent the class that you care about. Yeah. But these two boxes might represent the scale. So it turns out the vertical scale functionality that put the horizontal lines in the legend on the right-hand side, they came from a different class. So when you're looking at that one class, so there's one method in particular called drawScale. It calls a whole bunch of other classes and methods, and the developer has to choose, well, which ones are actually relevant to me. So the ones that involve Aserius core functionality aren't going to be relevant. So these are things that are going to remain in Aserius the developer is not going to reuse. But for instance, the scale is one specific example of something the developer would choose to reuse. Mm-hmm. So it's not just one class. So I tend to actually look at these nodes as more of a method and field level rather than a whole class level. Mm-hmm. Just because developers really want to reuse portions of classes. But at the same time, when you reuse a method, it has to live in something. So quite often, when you reuse a method, even just one method from a class, you're going to reuse its parent class as well. But you're just going to get rid of all the other stuff you don't care about.
And this part of the process where you sort of shop around and identify the things you're interested in reusing,
yeah,
is that something you're going to talk about more later?
That is in a slide or two.
Okay.
Yeah, so that's a really a key part of this approach.
Okay, great.
Because you could imagine just saying, well, I could just, just call these parts that I want and never extract them from the system. Just keep all of Aserius around. The problem with that is AltGPX is 10,000 lines of code, and Aserius is 3 million lines of code. So you don't want to have a 3 million line of code burden on top of yourself. So that's why developers take this extraction approach. Sure. And this happens actually in industry for a lot of different reasons. But one reason why you could imagine this extraction taking place, and this is something that one of our industrial partners reported to us, is that they had their system and it was out to clients that had been deployed, and they got a bug report and they had to make some fix. So they added a bunch of serialization functionality. So they added it to the branch that was out to the clients, but they'd already started the new work on their own code, and they couldn't just port it over from the maintenance branch into the development branch just because it wasn't the same anymore. It wasn't the same. They changed the system in some significant way, but at the same time there was code there that they could reuse. So one of our developers, what he did is he went and he copied this code. He pragmatically reused the code from the maintenance release within his own release and had to make a few changes, but it worked out all right. So it wasn't just a matter of managing branches better. It was just in performing a task in this way. So one of the key points here is that these reuse tasks are really unanticipated. The original developer didn't anticipate that it would be reused. Certainly they didn't modularize their code that way. And quite often, and in terms of ownership, for ownership reasons, the original developer isn't going to go and say, yeah, sure, I'll refactor this to make it reusable for you. That I would be happy to. And in the Aserius case, you can see why, right? The Aserius developers don't want to become a library of reusable components. And another main reason these industrial developers perform these tasks is a matter of ownership, right? So I do not want to take a dependency on your team. So I'm just going to take the code that you have. I'm going to make it my own. We're going to clone and own, I guess, which is the words we would use at Microsoft. So I'm going to clone it. I'm going to make it my own. And now I don't have a dependency on your team. Sure, I have to maintain this code myself, but I can make sure it moves in the direction I want when I need it to. So I don't need to wait for you to take bugs or add new features. I can take care of it myself. And these last 2 points we're going to come back to for the rest of this talk. So performing this extraction is highly manual. It's just a lot of copy and pasting inside of IDEs. And IDEs themselves don't explicitly support this. So when they added copy and paste to the IDE, they weren't thinking that you're going to be copying out whole classes and pasting them into new systems and then modifying them, right? It's more of a general high-level concept. So there's no specific support for this. So the hypothesis that really underlies all of this work is that by explicitly helping the developer locate the information that they need to perform a pragmatic reuse task, and then giving them some way to act upon this information that they've collected, we can improve their effectiveness relevant to current state-of-the-art techniques. So by improve their performance, there's 2 aspects that I think are interesting here. First, we can make them faster. So obviously some sort of tool support is going to make developers a little bit faster. That's not terribly surprising. But the other way we'd really like to help them is help them to scale out so they could attempt larger reuse tasks than they might otherwise manually approach. So those are 2 goals of this work. So the pragmatic reuse process looks something like this. The developer identifies some initial starting point of the system that they want to reuse and say, in the Azerius example, this speed graphic.drawChart method, this is my starting point. Then they go through and they plan the task and triage the dependencies. So they step through the structural relationships within the code and say, I want to reuse these dependencies and I don't want to reuse these other ones. And they make explicit decisions about whether or not they want to reuse particular pieces of code. And as a developer goes through and does this manually, they're going to be doing this anyway, right? You're already making decisions about whether or not you're going to reuse particular pieces of functionality, but we're going to try and make this a bit more explicit. Then the developer enacts the plan, so that is they carry out the reuse task, and they look at the reuse code and say, does this actually provide the functionality I need? And if they didn't, so in the Azerius case, if they reuse the code but they didn't reuse the scale functionality, they might say, oh wait, I want a vertical scale. So they'll go back and copy over that code and add that in as well. So you have the ability to go back and have this feedback loop to really update any decisions you've made. And at any point, of course, the developer can choose to abort the task. But what we really want to happen is we want the developers to be aborting this task for a real reason. We don't want you to abort the task because you say, oh, I have a gut feeling that this is a bad idea. Or, that's a peer-to-peer BitTorrent thing, and I'm a GPS developer, so this shouldn't work, so I don't want to do it. You don't want wishy-washy answers for that. We want to say, I'm aborting this reuse task for this explicit reason. We want the developers to be able to make an informed decision. And of course, at any point, they can choose to just give up and re-implement the feature. And in this case, what we really want to do, if they're going to go off and re-implement the feature, we want them to be making this decision before they've invested many days in the reuse task. So we want to help them make this decision in a more upfront manner. So the next step here is to talk about planning. So what exactly is involved in a pragmatic reuse plan? So from our scenario at the beginning of the talk, what the developer really wants to do is say, which parts of Azerius are involved in this piece of functionality that I want? So how can I plan this out? Which which methods, classes, fields are actually involved in this code? So the primary goal of planning pragmatic reuse tasks, again, is to come back is to promote this informed decision-making process. So we want the developer to say, hey, I'm reusing this code and I'm reusing it for this reason, or I'm not reusing this code and this is why. So we want them to say, to at least understand at the beginning of their task the pros and cons of performing any pragmatic reuse task. The other thing is we really want to help developers navigate through this unfamiliar source code. So you're going through and you're looking at an editor. And when you're looking at that editor, there's a whole bunch of textual links that are representing structural dependencies. So here's one method call. So when I'm looking at this editor is the implication of this method call. It's hard to say, what's the scope here? What am I looking at? So we want to help the developers actually understand the scope of, what's the cost going to be of me just reusing this one method call? Is it going to be having to take hundreds of other methods and classes? Or is it just going to be a simple static call? Like what are the implications? So we want to help them actually navigate through this source code. And the other thing that's really important is we want to help developers keep track of the decisions they make. So when you think about it, when you're going through someone else's code, you're going to be stepping through the code and you're looking at all these various editors. In in a short amount of time, you're going to have 15 tabs open in your IDE. You have all these different files, and you've looked at them in all these different ways, and they're using all these new identifiers that aren't familiar to you because it's not your system in the first place. And it's really hard to keep track of all of the information that you've assimilated. You know, which classes am I reusing again? What am I not reusing? What decisions have I made? Have I just contradicted myself? You know, so we want to help developers actually keep track of these things in a very explicit manner. So we're just going to talk about this in a bit more of an abstract form. So here we have speedGraphic.drawChart. And speedGraphic.drawChart is this one method in a series that represents the core of the functionality the developer wants to reuse. And each of these other circles around the periphery represents either method calls or field references that speedGraphic.drawChart calls or references. So these are direct structural relationships of this one method. And ultimately, what the developer is trying to do is to triage all these dependencies and decide which ones am I going to reuse and which ones aren't I going to reuse. So the first thing our tool can do is say, look, these are the common dependencies between your system and my system, because I know you're reusing code from this system, and I know you're reusing code within this system, because the developer can specify both of these things. So we can say, these are the common dependencies, you don't have to worry about them.
Yeah. You're just doing name equality?
Yeah, just name equality. So if there's collisions, it won't work, but it's turned out in practice that this hasn't really been a big problem. So yeah, it's just by names itself. So in the Aserius case, what each of these yellow nodes represent are commonalities between these two systems. And both systems use the SWT graphics toolkit. So in this case, they both have Canvas. So here's Canvas, and we don't have to worry about any dependencies on Canvas. And just by removing these dependencies up front, the developer is freed from having to actually investigate them in depth. Right? They don't have to go through the code and say, is this common or is it not? It's taken care of for them automatically. And I just want to mention up front that this is actually an abstract representation of the tool itself. I'll show the tool at the end. This is just a bit easier to visualize. The next thing the developer wants to do, and what we're going to do here, is go through the decisions they can actually make about a specific structural dependency. They're just going to say, what code do I actually want to reuse? And if I want to reuse it, I'm just going to annotate it in green. So I'm not going to remember that I want to reuse it. I'm going to actually right-click on this piece of code, and I'm going to say, I want to reuse this code. Or right-click on this abstract dependency and say, I want to reuse this. And now this is recorded. It's explicit, and we use bright colors so the developers can quickly tell between one decision and another. So there's only going to be a few, and it turns out to work very well. So the next thing the developer is going to do is say, well, they're going to go through the dependencies and find a dependency that they don't want to reuse. Say, this is not relevant for my task at all. This has something to do with BitTorrent, and I don't care about BitTorrent, so I'm going to reject this dependency. The third classification of dependencies is we call remapping dependencies. So, and this is actually quite an interesting type of scenario. So you can imagine looking at this method, speedGraphic.drawChart, and it references a color constant. You say, hey, color constant, but that's an Aserius color. I don't want to use Aserius colors. I want to use my own. And I already have my own color constant. So let's just go and automatically remap them from the Aserius constants to my own. So you can just say, I'm going to remap this. I'm going to remap it to my code. So when we enact the plan, which we'll come to later, we can just update those references automatically. We can do the same thing with methods or class relationships as well. So this is a way for the developer to reuse the functionality without actually reusing the code. So, yeah.
I wanted to ask a question about the rejection of code.
Yeah.
So how can I just decide I'm going to reject a piece of code? Like if I'm talking about classes, so this method refers to this class, the method that I'm calling at the center. If it refers to the class and I say no,
yep.
I can't, what am I, rewriting the method or refactoring the class? In some sense, what I really want to do is drill down on that class and say, well, what exactly in this class do I need? I'll accept that and return everything else.
Yeah, so each of these nodes represent specific methods or fields. So if you reject something, you're rejecting a method within that class itself. So you're not.
How can you just reject it though?
You can just say, I don't want to reuse it. So okay, think about it in the manual case. If you reject something, you're just going to not copy it. So you already make these decisions, right? You already decide this is what I'm not copying. So you can do it. And what you're going to do is you're going to not copy it, and then you're going to go to any part in the code that references the thing that you chose to not copy, and you're going to have to make some modification manually, right? So, and we're going to get to how we can do those modifications in a more automatic way in a few minutes. But you could just think of it as the not copy decision. It's just that you're explicitly making it. So instead of making a decision by just not moving the code manually, you just say explicitly, I don't want to reuse this. And now you have an idea of how much you didn't reuse instead of just saying how much did I not copy, which is sort of it's a more abstract concept.
Is there an upcoming slide with the actual UI for doing this?
Yes.
Okay.
And it's just one because, yeah. The UI is a complicated thing because the thing is it's a process where you're building up this graph as you go. Right. So it's kind of hard to show.
So I'm trying to get a sense of the workflow. So I guess, in some sense, this plan that I'm building is a kind of work item that persists for a while, that I work on for a while, and I may be doing explorations off to the side, like, oh, this thing uses this class, but its name is not meaningful to me, so I don't know whether to accept or reject it, so I have to kind of do some code understanding for a while to get to know it, and then I'll make my final choice. Right?
Yeah, so the way it works, and I'll just take a quick aside to say, we provide sort of an abstract graph representation. So it's a graph, and you can go through and say, these are the dependencies, and I can look at each of them. And at any time, you can just right-click on any node and say, just take me to the code, because I know code. Developers use code all the time. It's what they're used to. It's back to the editor thing we talked about at the beginning, but it's what we're familiar with. And you can go through the code and say, oh, yeah, this is relevant or this isn't, and go off on some random exploratory path and just come back to where you record the decisions later. So it's just another view within the IDE. It's fully integrated into your development environment. So you can take any path you want. You can switch off. You can do something else for an hour and come back to it. It's not a problem. Like, the idea isn't that you have to stay in this planning task the whole time. And it turns out it's actually really valuable because you can go for lunch and not forget all these decisions you've already made about this reuse task. Or someone can come and interrupt you, ask you a question, and you don't forget what you just decided because it's explicitly recorded. But yeah, the workflow is really, we're just trying to augment what you're doing already. So you're already stepping through the code in an editor. All we're really doing is providing a facility to better outline what dependencies actually exist using a visual abstraction, and actually recording the decisions you make themselves. So you're already in there. You're already going through the code. We're just adding a very small amount of overhead on top so that you actually are recording what you're actually doing.
I guess, the alternative would be something like, a wizard, one of these modal dialog boxes with, where you keep hitting the next button, right?
Yeah.
And that would be like exactly the wrong thing, if I understand correctly, because people's expectations is that as a 90% automated task. Mm-hmm. And so they just hit next until it goes away.
Yeah.
And this isn't like that at all. This is basically people making explicit engineering decisions and therefore recording that in a sort of work artifact makes a lot of sense.
Absolutely. So we have this, well, I'll go in 2 slides, I'll say what's negative. But we have this structural graph. So you can just say, I want to reuse this piece of code, find me everything that's related, and let's just do it automatically. Okay? And not keep the developer in the loop. The unfortunate part is that, the fortunate part is that we have developers, and developers are very well paid, and they're very highly trained, and they're good at what they do. So let's let them make these relevant decisions. They know about these remapping things, right? They can say, I want to make this explicit remapping from this color to my own, and I can make this explicit decision saying this code doesn't do what I want. And the reason the wizard approach doesn't work is that developers don't work that way. They're not as highly structured as would be happy going through some wizard. They want to be able to go and explore some path, step out, and explore another path. They really want that flexibility. So it turned out having some sort of wizard approach certainly wasn't anything we wanted to investigate. Anyway, so if you go and you make all these decisions, you end up with a picture, a direct dependency picture that looks something like this. Okay, so it seems like a lot of decisions that you've made, but really, when you're navigating through the code, you're making these decisions anyway. All we've done is add on this level where we're actually recording. So in this slide, we've stepped down and looked at all the structural dependencies that are relevant to this feature. Now, if we did it in an automated way where you're just clicking next on a wizard over and over again, you're going to end up reusing everything that's on this screen. And there's 194 different methods and fields on this view. We can see right here, you've chosen to reject this one method call, and it has some rather large implications for this reuse task. This is all BitTorrent stuff we don't care about. And it was really nice that this is taken care of for you. So this is why we really want the developers to be involved in this investigative process, because they can have these kinds of huge savings. And this isn't uncommon. And in fact, I actually would guess that this picture is somewhat smaller than we would normally see with a more integrated piece of code. So here we see 2 specific decisions made by the developers have restricted large parts of the tree that the developer doesn't have to reuse. And if we just step back from this and hide all of those other nodes that the developer hasn't investigated, they end up with a plan that looks something like this. So this represents 5 classes, about 440 lines of code, 450 lines of code. And this is the Azerius pragmatic reuse task in its abstract form. Now I'm going to show the prototype tool that we developed to help developers with this. And I just want to say up front that it was a prototype tool, and the reason I don't belabor it too much in this talk is that it has some problems, and we've gone off and fixed them. So I just want to I'll show it briefly, and then we'll talk about what's wrong with it later. So we ended up with a visual abstraction with something like this. We gave developers a graph, because when you go up and you draw your pictures of your code, developers hit the whiteboard, and they start drawing boxes, and they draw arrows, and this is how they think about code. It's a graph, and really it is. So that seems like a natural way to go. So we gave them this graph, and it had some shortcomings, and I guess I'll instead of talking about them on the next slide, I'll just talk about them right now. When you're going through and you're navigating a graph, and developers don't have these graph widgets at their disposal all the time, you go and you open up some nodes. So if you go and you double-click on DrawChart, it opens up all of these direct dependencies that DrawChart has. How do you decide which one to go to next? It's not very, it's kind of random. You know, whatever the layout does, I'm going to go to whatever's on top, and that might not be the most relevant, but that's just the way it works. Just like normal development environments go and they order things alphabetically. It's like the importance of alphabetical ordering isn't all that much, right? Maybe you start like naming the methods that you really care about with A's just so they get to the top of that list, but that's not really good practice. Or underscores, especially underscores, can be handy. But as the developer steps through this graph, it starts to become a mess. When they open two nodes and they have them open side by side, right, they can tell that this method has a whole bunch of out edges, and this method has a whole bunch as well, but I can't tell which one's worse, or which one has more, or I can't even tell explicitly how many there are. And there's all kinds of UI you could imagine to make this better. Certainly, the graph drawing community can help with this as well. Yeah.
What analysis are you doing to find the dependencies between the methods?
Yeah. So what we do just up front when you start a pragmatic reuse task, you just say, "This is the code I want to reuse," and we just do a lightweight static analysis using the ASTs. So it's within some project.
Provided by Eclipse already?
Yeah. Yeah. Well, I mean, however you generate your AST. We don't have a dependency on that.
But you implemented yours in Eclipse, right?
Yeah, ours is implemented inside of Eclipse. Yeah, so we're just crawling the Eclipse ASTs themselves. Anyway, so I guess I won't spend too much time on this, other than to say that there were some drawbacks that our users found. So we wanted to go. I guess the reason we found these drawbacks, we went to our industrial partners again. So of the people who completed our first survey, it turns out 4 of them were Java developers working in Eclipse, so we gave them the tool and said, "Here, plan some pragmatic reuse tasks. Try it out. See what it does for you." So the 4 industrial developers ended up reporting on 6 different pragmatic reuse tasks that they were actually performing in their day-to-day business. So for each of these tasks, we had them tell us, how big is this task, what's its scope, what's involved, and what are your experiences with using Gilligan, which is the tool we created, to perform these tasks. And what these developers really found, and this was really interesting for us to hear, is that explicitly recording the decisions really helped them out. And the reason it helped them out is they could say, "Look, I'm looking at this picture. I see a lot of green. I don't see a lot of red. This is good." Or I'm planning a task. We had a couple of developers plan tasks that were horrible ideas. They planned it out, and the task was like 2 green nodes and a whole bunch of red nodes. They had the code that they wanted to reuse was heavily coupled on its originating system. And they decided right up front, this is a bad idea, and I'm not going to pursue this task. But they could say explicitly that this task is going to be rejected for these very specific reasons. Second point is that planning really did reduce disorientation according to them. We didn't measure this in any way. But the developer said, Bob came over and he started asking me questions, and I had to stop what I was doing. But I went back and I was like, right there. The plan was in front of me. I knew where I was. I knew what decisions I'd made, and I knew what I had to do going forward. One thing that was quite interesting as well is that these developers felt that they could scale out to larger tasks. So they knew what size of pragmatic reuse tasks they do already. We know how much code we can copy before we start to get overwhelmed. But here the developer said, well, what? I kind of feel like I could plan a larger task than I might normally attempt. And while we don't have any direct feedback to see if they actually followed through with these tasks, it was just a perception that they had themselves. Now there were 2 really large negatives to the visual approach that we came up with. So the first thing was that when tasks started to get beyond 10, for instance, about the 10 class level, there were too many nodes on the screen. Developers couldn't keep track of what decisions they're making and when. And we looked at various methods for collapsing nodes and for clustering nodes, and it just ended up, nothing ended up really doing what the developer wanted. There was just too much for them to consider. And the second thing that was really interesting to us is that it was hard to systematically work your way through the graph. So you have these nodes and they're all over the place, and you start at the top and maybe you work your way clockwise. But when you open a new node, the layout algorithm readjusts things, and orders change. And even if you have a very stable layout algorithm, nodes are still going to move because you're still going to have to make more space for new nodes on the screen. So we had a lot of problems with the developers actually going through these graphs systematically. Yeah.
Do you think that a lot of these problems can be solved by having a better graph layout, or perhaps just because the code they were trying to reuse is spaghetti code?
I think both of those could be true. So about the spaghetti code thing, I think that's not an uncommon case, the code that they want to reuse in the first place. And that's okay. We can't say that that code is wrong because it already exists and it already works in some context, right? So I think that's the nature of the data, is that it's going to be a big graph-like, it's going to be a spaghetti mess. It's just how it's going to be. I think I could have certainly spent the remainder of my PhD working on graph layout algorithms to try and resolve this, but instead of doing that, we went back and said, well, what are the developers actually after? And I'll talk about that on the next slide. So instead of trying to make the graph better, which we investigated for about 6 months, we looked at all the latest research and how can we fix this and fix that and fix the other thing, we decided to just abandon graphs altogether because it just wasn't the right approach. So instead, we looked at, well, what information do developers actually want? What problems do they have? So we went back again to the drawing board and we confirmed informally with our industrial developers, but we didn't actually involve them directly in this step until we created the artifact. But the dependencies are really these little textual links in the source editor. And when you're looking at one textual link, you can't tell its implications. Like that one reject node, you couldn't tell that you're rejecting 100 other nodes just by looking at the text. It's just not clear. And developers are used to using editors, and they're used to using lists, and they're used to using trees. And they might think of code as a graph, but they don't use graph widgets all that much. It just doesn't fit. It takes a lot of screen real estate. It's just not helpful for them. So what we wanted to do is develop a more simplified way for developers to actually interact with these dependencies. So we said, what do the developers actually want to know? And it turns out you don't want to know all about how tangled things are, because that's not really important. What was important is just what is the expense of this dependency. So if I'm clicking on this one dependency, how many indirect child dependencies are there? And in the graph, you don't see that until you've clicked on and expanded a whole bunch of nodes all the way down. And you can imagine adding a tooltip to the graph so that it would show that information for you as well. Yeah?
Now, is that a question you want to answer about a particular identifier, kind of what's the depth of this identifier, or is it with respect to the stuff that I've already pulled in, or gee, if I pick up that versus that?
Yeah, so I think these numbers can be used in a number of ways. So if you're thinking about, I'm either going to reuse this or I'm going to reuse this, you'd like to know, well, which one is going to be more expensive. So having just, if reusing this is going to cost me 10 other methods and this one's going to cost me 14 classes, you're going to go with the smaller reuse task if possible. Right? So the developers are trying to choose.
Is also a part of the decision-making process, right?
Yeah, so while I would agree, it turned out to not really be the case when developers were planning these tasks. So we expected there to be more like this. So when you're looking at the graph, you can see that this part that I've accepted and this part that I've accepted both use this thing that I've rejected, right? And that might be significant, but you've rejected it, so you don't care. And I know it seems odd, but when developers actually use this, so I'll show it in the next slide, but when a developer actually used our system, who had used the graph system before, they had no problems. They went immediately to say, these are the decisions I'm making, this makes sense to me, and I'm okay with this going forward. So you can still go back to the graph to look at it statically and say, this is what the graph would look like. We don't let people edit the graph at all anymore. It's something you just look at. It's just pretty picture. You can see that tangling if you want to, but it really wasn't something that developers actually needed to do, because you'd go through and you'd be looking at the code and you'd be making these decisions informally already without knowing that those links were even there in the first place. So in the manual approach, you wouldn't know that information. So in this case, to not show that again, it turned out to not be a big problem. I know that seemed odd, but it's counterintuitive, but it's what we found by actually showing the tool to people.
I don't know that holding up, this is the way it is today, is a compelling argument. The fact that the tools suck today, it's not a reason to make the tools that you develop suck. Now, but on the other hand, let that observation that developers deal with editors, lists, and trees, and not spaghettigram visualizations is interesting about it.
I guess we were there's always this counterplay between adoption and just going out there. And we really wanted to go with something we could get our partners to actually try and get them to use and they were comfortable with. Because there's this whole training issue, like we ran these remotely, so we couldn't go into the workplace and train them on the tool and that sort of thing. So we sort of wanted something that they could understand. And I guess the reason why I'm holding it up to the plain case is this is just the information that developers are used to working with. And it was information enough for them then. So we don't...
No, it's not. These reuse operations you told us before are incredibly difficult and error-prone.
Yeah.
So it wasn't sufficient before. So holding that up as a gold standard or a meter of any sort is wrong.
Yeah. You figure out a better way. I guess what I'm trying to say is that we felt that the graph approach, while it was intuitive to us and seemed like the right approach to undertake, had a lot of drawbacks. It certainly in terms of usability and scalability. And these were things that we felt we could have potentially resolved, but we weren't really equipped to do so.
No, I'm totally down with you
Yeah.
rejecting the graph visualization approach.
Yeah.
I'm very happy with that.
Yeah.
Anyway, this is maybe a point that we can take up later.
Okay, I understand where you're coming from. I guess the problem for me is I know what's coming, so I have a bit of a different perspective. I'll just say right now to answer your question is that developers have been very successful with the new paradigm where before they failed. So this next result it's a little different. Okay, so this is what the new plan tool looks like now, and this seems a little weird, but what we have here is a core concern pane. So the developer says these are the things that are key for my reuse task. So anything that they can add anything to here. So you can think of this as like a feature planning tool or a concern mapper, where you go and you add the elements that you really want to reuse to the leftmost pane. And if you select any element here in the leftmost pane, it shows its direct dependencies in the center pane. Okay, so it's only the direct dependencies of anything that's selected. And if you select anything in the center pane, it shows the transitive closure in the rightmost pane. Okay, so if you want to see the complete transitive closure of anything you've selected over here, you just select this element. It turns out it was so helpful that we just made it so you double click on it and it automatically selects everything in the center pane and it shows you the transitive closure right away. We also add these numerical indications showing this is the number. There's 17 direct dependencies and 26 indirect dependencies. So just you have some sort of idea of the scope of the dependencies you need to work with. And at any point you can click. It'll add things to your core dependency view as you see fit. So it turns out unfortunately the screenshot's from a different task than we've been talking about throughout the talk. But it turns out in the speed graphic case, you're going to have speed graphic here. And then you're going to end up running into this code that represents the scale functionality. You say, well, this is of key interest to me. So you go and you drag the scale functionality over the leftmost side. So you have an idea of this is the code that I actually care about. The nice thing about this is the developers can quickly go through these dependencies and just click, and it automatically shows here are all the dependencies. And you can scroll up and down. So you can slide up and down with the scroll bar, and you can see, well, here's a decision I haven't made yet. Or here are two decisions that I also haven't made yet. So you can quickly see what have I decided and what haven't I decided about. So it just gave them a way to really quickly investigate these various paths through the code. So instead of opening lots of different editors, they can immediately see this is the dependency, this is numerically how many things are going to be underneath this, but if I want to investigate it further, I can look and see these are what these dependencies actually are.
So if I understand the three panels at the top, it's basically a tree view in which the topmost children are in the left panel, the grandchildren are in the middle one, and then
everything else
all subsequent ones are in the third one. So can you walk me through the rationale of why doing three views instead of just one tree view that combines all three?
Yeah, and I guess this was mainly so the developer, it was a matter of like maintaining focus of what you're actually interested in. So here you can say, I'm interested in start listener. Start listener is what I'm investigating right now. And you can imagine just drilling down through a tree. The problem is the developers ended up doing lots and lots of drill down operations. So we started off with a single tree. Okay. And this tree ends up getting really, really long. Like it ends up being really deep. And the depth the depth is interesting in the direct dependencies. So knowing what is an immediate child is very interesting. So that's why we added the center pane. So the first thing you want to say, what are my immediate dependencies? And that ended up being very relevant. So we promoted this to be a top-level pane. And beyond that, we just want to say, well, what are the children? We don't want to, the developers didn't want to keep stepping down and stepping down and stepping down to see what the whole call chain was. They just want to say, yes, these are dependencies that I have to worry about, but they're not immediate dependencies. So that's why it ended up being 3 panes across. I guess also it was somewhat influenced by Smalltalk IDEs had this sort of 3-pane notion of looking at dependencies in Smalltalk programs, like the old visual age systems. And I guess it just sort of seemed like a natural way to put this out there. I suppose the industrial developers we were talking to at IBM at the time, when we were designing this, they might have been influenced in that way as well, so they thought it was all right. But really the main thing was that the developer wants to say, I'm focusing on this, these are my direct dependencies, and these are the things that I care about the most. So it was really making that very explicitly clear from the transitive dependencies. And then the developers also ended up saying, well, I also want to see what these other things are. And just having all these different expansion operations wasn't really important. Like how we got to this point didn't seem to be as important as the fact that it was there in the first place. And I know this comes back to the point that Gina was making earlier, just about whether or not these relationships actually matter. And all I can really say is based on the feedback we got from developers that this was good enough for them. I know we're comparing to an imperfect measure, being what developers are already used to, but they could effectively locate a lot of the dependencies in this manner.
And sorry, one last question. So how does that leftmost panel get populated?
So right at the beginning of your task, you say, I want to reuse this piece of code. So you just select some piece of code and say, I'm going to start my reuse task from here. So you just choose some element and say, this is the start of my task. Or conversely, you could click on some code in an editor and say, add this to my core concern view. So you can just say, I want to start from here. So you just have to, as with anything else, you need to choose some starting point, and that's just based on whatever the developer thinks is relevant.
Does it make any sense to promote stuff from the middle panel to the leftmost one?
Yeah, absolutely. So what happens in this case, you can say, well, I'm interested in reusing start listener, but it turns out that get log4j server is also relevant. You say, and this provides functionality I actually care about when you actually look at the code itself. Say, this is key to me, and you just move it over to the leftmost panel. So there actually is, there's a context menu item to move things directly. There aren't very many options we give the developers, and one of them is to move things to the core concern pane, because as you investigate the code, you say, this is code I actually want to reuse. Like you can imagine this is the boundary of the code that I want to reuse, and then you could imagine this being anything that you've annotated as accepted, but really you have the core concern you want to reuse, and this is other stuff that I'm going to reuse, but I'm not really so keen on, but I just have to take it. And then there's all the stuff that you've rejected.
And sorry, one I swear to God, this is the last one on this slide. So is there any sense of a progress bar here? I mean, do I know how far into my plan I am?
Yeah, so the answer is directly there's not. So you can just, you pretty much the easiest thing to do is to select anything here, and you can just scroll down the transitive dependency view, and you can see what's left. And that seems indirect. But one thing we also have is the ability to say, am I complete? So you can go and you can click, because we know what decisions you've made. We know what you've viewed and what you haven't viewed. So there's the little checkbox here. You can validate your plan. And it'll go and highlight, these are the things you haven't yet considered. So you should look at these dependencies as well. And that again, compared to doing it manually, this is much better, because when you're going through the plan, going through code, you don't actually know when you're done. So we have that extra step. So we wanted to perform an experiment to say, can developers actually use this to locate relevant structural dependencies? And the reason why actually locating structural dependencies is important is that if you're making a decision whether or not to pursue a reuse task based on imperfect knowledge, you could choose to pursue a task that might not be such a good idea. So what we did is we gave the developers 4 different tasks, and we came up with, very carefully came up with a perfect measure of these are the dependencies that exist in the system. I know that we have a time issue. So what we did then is we compared developers' effectiveness using a manual approach, so going through with an editor or using our tool, and just compared, well, how close to the correct answer set did they get? So I didn't mention before, there were 6 developers performing this experiment. So overall, what ended up happening is that developers using an editor-based approach, we were able to find about 47% of the structural dependencies within a system, which was much lower than we expected because developers go through code all the time. They're used to using editors, but they would look at specific dependencies and just pass them over and not think they were interesting. Or they would say, oh, this is common between the two systems, and they'd be incorrect. And they made a lot of mistakes that way that ended up having them miss a lot of opportunities. And developers using this new tree-based approach were able to find the correct structural dependencies up to 97% of the time. And the reason why there was this gap here, why Gilligan did so poorly, is in the first iteration of this tree-based tool, it turned out that it didn't accurately show class hierarchy relationships very well. And those ended up being really important for the third task. So we updated the tool based on that. Yes?
So did you have developers do the task manually first and then use the tool?
In this case, it was random. Was it randomized? I'm trying to remember. I think what we did is we did it with the tool. Everybody used the tool first because we wanted to have developers at least as comfortable as possible with the manual approach. We wanted them to be comfortable with the concept of the task before doing the manual approaches later. I guess we wanted to try and favor the manual approach. So we didn't want to randomize it because we didn't use that many developers. We wanted to always do it second, just so they'd be more familiar with what we were actually asking.
But you did have the same developers perform the same task twice.
No, we didn't. So each developer, each of these bars represents 3. So the 3 developers did it manually, and 3 developers did it with the tool, and then they switched on each task. Yeah, so it wouldn't work. There's too much of a learning effect to apply the same developers to the same task. It didn't make sense to do it that way at all, and that would have been perfect, but it just doesn't work out. It just doesn't work out. Okay, so sorry. So I just wanted to talk briefly about enactment before we have to wrap up here. So what we have is the developer has come up with a plan in this planning phase, and they need to actually go and enact it to actually make this reuse task take place. So what they've done is they've accepted some code and they made a whole bunch of decisions, and they've extracted the code into some intermediate representation, and now we can see here where since they've made these decisions, we can see that these arcs have specific problems. There's going to be dangling dependencies in many different places. And once we integrate the code, we can remap. The remap dependencies end up pointing to dependencies in the developer's own system, but these rejected dependencies need to be mitigated in some way. So what we want to do is we created a tool called Procrustean. And what Procrustean does is it takes the pragmatic reuse plan and automatically enacts it for the developer. So instead of them just doing this thought exercise where they make up this plan, it actually does something for them. So you can see you might have used a lot of program understanding approaches that help you understand something, but they don't go that next step of helping you with this task. So we really wanted to take this plan that you've put some time into and actually use it to drive the reuse process. So I just wanted to give a quick example of what actually happens, because this comes back to Andy's question from earlier. So for this bit of extracted code, we can see that there's 3 dangling dependencies. Okay, so the colors objects represent fields that you didn't reuse, and we chose to reject this aemonitor.enter method, so that method call doesn't exist anymore. So the first thing we wanted to do is update those references in the colors class, and we again just do this by manipulating the code. Instead of pointing to colors.blue is darkest and colors.blue is midlight, we just modify the code so it points to whatever fields that you specified when you made the remap decision. Because when you make a remap decision, you don't just say I'm remapping, you also say I'm remapping to this. Okay, so we just modify the code. And it turns out dealing with remapping operations is generally fairly easy, fairly straightforward. Now for rejecting this method, we're going to do the simplest thing you could possibly imagine. I would guess this might anger you in some way, but all we're going to do is just comment it out and annotate it, okay? And it turns out that just commenting it out and annotating it works fairly well, and until you end up with a situation like this. Consider getClientArea. What happens if we chose to reject that? So now we can say we don't want getClientArea. Well, we can't just comment out that portion of this statement. Well, we can, but that's just going to cause another problem. Instead, what we do is another thing that's the simplest thing possible is we just comment out the whole statement. Now, this is a problem for later on in this method, right? Because now bounds is not declared and it's just not going to work. But what all this does, and the reason why this is okay, is that it calls out to the developer when these compilation errors arise later, you made a decision that somehow contradicts something that's important, and you need to look at this. So maybe you don't reject getClientArea because you need this value. And it turns out that while that seems a little bit weird that we're still promoting there being some errors, in practice, the developers are able to use it quite effectively. Yeah.
So what they were rejecting was the definition of get client area or the call to get client area?
Yeah, so when you read, so this is a thing, in these plans you're making a very general decision. So yeah, you're representing reusing the definition of get client area, which means every call to get client area, no matter where you make it, is also rejected. So
there'd already be an error message, so why do you need to worry about commenting down?
Well, I guess the reason why we do it is because in these cases, in a lot of cases, it ends up not being a problem because you end up rejecting rather large swaths of functionality. Like, I just don't care about anything in here. And I guess in these cases, sure, it brings up a compilation error still, but instead of choosing when or not to apply or reject change, we just make them all and add this little annotation so developers can search for them and say, these are the reject things I need to consider. At least you know looking at the code that you did reject this.
I guess this also has the potential to compile,
Yeah, well,
as opposed to
sometimes
leaving it as
sometimes it does. Yes. Yeah.
So I'm assuming that one of the reasons you would just use a comment like this is because when they're actually going to view the code after you've done your helping task, you no longer see yellow, green, and red.
Yeah. Well, I mean, we can still add those color annotations. Like I guess they're not still there, but I mean, it wouldn't be a technical problem to add it to them. But yeah, when you close down your editor and you come back the next day, yeah, they're going to be gone.
Well, if you were to, have you considered the decision of instead of commenting out that second section, just leaving it showing yellow, green, and red, and then it's immediately obvious to the developer.
What they're supposed to
an error on line X that, oh, look,
Then they have to go through all their code
Yeah.
looking for red.
No, because you get the errors.
You still get the errors, yeah. So I guess
When you go to why it's an error, you know, oh, it's because I rejected some code.
we did it just to be consistent. So we make all the changes, and it's going to cause an error anyways, but sometimes it doesn't, and that ends up being okay. Sorry, Tom?
Have you considered creating mock classes to sort of close off the system?
Absolutely. So when we first started this work, there were two decisions. You either reject something and we just get rid of it completely, or yeah, you create some sort of mock object or you create some sort of a stub that can fill this need for you. And in the end, we ended up not building that functionality. And the reason we didn't is that in the cases that we've tried on so far, we haven't run into the situation where it ended up being that much of a problem. But I believe if that was the case, that this is something that would be worth investigating. We just haven't done it. It's just something, so it's not dangling.
Some class that I depend on, I don't need all of it, but I need these three parts.
Yeah.
And just abstracting that out, then you could have it compile,
Yeah.
sort of in isolation.
Yeah, I guess there's two things. By still having an error, you still have to fix something instead of having something that you have a mock object but doesn't do anything, and that might introduce more problems later on. But I think
I think an interface is really what I'm thinking.
yeah, I think there is a middle ground here that we haven't explored very, very carefully. So we did a larger experiment to say, does Procrustean really affect the effectiveness of a developer actually performing a pragmatic reuse task? And what we did is we gave Procrustean to 4 industrial developers and 4 experienced grad students and said, enact some plans. Tell us what your results are. And more importantly, we wanted to see if they were actually successful. So we applied. They tried these tasks, and we tried them. They had to pass a specific unit test harness that we gave them so they could see if they were successful or not. So they had a 60-minute time limit just because we couldn't have them take forever. So these are what the results look like. So here we can see there were 4 cases that developers actually failed to complete their goal within the 60 minutes. And this surprised us because we thought everyone would complete and that there would just be a time difference. And this one developer, he gave up early. After 24 minutes, he said, forget it, I'm not going to do this task. Like, in reality, I'd have given up on this task, so why would I beat my head against the wall now? So what's interesting here is that 4 of the 8 manual cases, developers failed to actually complete the pragmatic reuse task. And in these 2 tasks, we know that they're good tasks. We've done them. They were things that arose out of practice. They're not things that we just generated on our own. So these were good reuse tasks. So it's really interesting to see that 50% of the manual approaches failed. Yes?
Are those correlated? Like the same person who did the green T1 manual task also did the red T2 manual task?
No. So the same person who did did the T1 manual did the T2 Procrustean because they switched. They did one manual and one with Procrustean. So this person is the same as this person, and this person is the same as this person.
Okay.
And it turns out that of the failures, 2 of them were grad students and 2 were industrial developers, so it wasn't skewed one way or the other, but I mean, it's only 8 people. And it turns out the result that wasn't as interesting to us is that developers using Procrustean were 50% faster, where they took half as long. And I mean, that's not terribly surprising because we are automating all this work for them. Yes.
So when you define success, I mean, it's more than possible that, you reject that one line of code at the beginning of the method, and it looks fine to comment out, but then that at runtime affects, some side effect and blah, blah, blah.
Yeah.
So if that were the case, then would that be failure?
Yeah, because the code wouldn't work. So we ran it against the unit test harness. So we weren't just saying make it compilable. We were saying make it compilable and make it functional. So the developers actually had to make some changes.
How did you pick the tasks? How did you balance them and figure out that they were actually easy enough to do?
To be pretty honest, one of them was the Azerius task, which came out of some Reuse task that someone had done in a lab previously. And the other was reusing a portion of metrics. It also came out of another research project where somebody had performed a pragmatic reuse task. So they were just cases that had happened. They happened to be similar in scope, and we just applied them.
And just one more question about the task. From your anecdotal knowledge of the task being done prior to this,
Yep.
had any of them taken less than an hour?
Yeah, so we thought everyone would complete. We thought the 60 minutes was arbitrary.
It
But
wasn't like a 3-week task.
no, absolutely. Well, re-implementing both of them was over 400 lines of code, so we knew none of them could do it even in less than 3 hours. But we expected the reuse task, performing the reuse task, would take half an hour to 45 minutes. Even in the manual case, we didn't think it was going to be that bad.
And so this is the time for both the planning and the enactment?
No, so we had to control for something, so they were all given plans. Everyone has a plan, and their plans were all complete.
And how were those plans embodied in the manual case?
They were still given the plan and its representation, so they could still go through the tool and see what all the decisions were, and we had them written out on paper as well, so they could say these are the pieces of code you actually want to reuse. So they still had access to the whole planning tool. They just didn't.
The only thing it didn't have was the go button that
Just
generated the comment.
Just the go button.
The commenting.
Yeah. I don't know. It was this much of a difference.
how
So I'll just say the reason why we said why was there such a big difference? Like it seems really weird that just adding this one go button was such a big difference. So we wanted to look at what is actually involved in doing this manually compared to the tool-based approach. And we said, what would a perfect developer do if you made all your decisions right? How long would it take? And it turns out that it looks something like this. So in the manual case for T1, the developer would have to make 60 decisions if you made every decision correct in the right order and you never ever made a mistake. And I mean that's kind of unlikely, but if it went that way. Whereas if you used the tool-based support, there were 2 errors. And now again, this isn't terribly surprising. We automated a whole bunch of this copying and error, compilation error fixing for you. So it's not a surprising result that there was a huge reduction in decisions the developer has to make. Yeah.
Sorry, what is a decision in this case?
So.
Because they both have plans.
Yeah, they
so
both.
This is not a plan.
Yeah, so
decision.
I guess it's a decision they have to make when resolving compilation errors. So I didn't want to call them resolving. In this case, there were 180 compilation errors, but really it came down to 60 decisions. Like a whole bunch of them were the same, so we just lumped them into decisions. So we wanted to group them conceptually, because that's how developers do it anyway. Oh, I did this. Well, that's the same as I did over here, so I'm just going to do it 3 more times. So it was just a way of not getting bogged down in the specifics of how the Eclipse compiler works. Yeah.
Did you find out how much time in both cases was spent physically copying and pasting code versus fixing errors?
No, but
Since obviously Procrustean turns the copy-paste part to 0.
To 0, yeah.
So then the whole time it's just fixing
In
errors.
both these cases, it's not a lot of copying, so that isn't a big overhead. The really surprising thing here is that these 2 and 4 errors are much harder to fix than the average of these 60. So these 2 errors represented some high-level mismatch between the plan and the actual enactment. So not all decisions a developer has to make are equal. Okay, and this was really important to us. What happened here is the tool-supported developers in the Procrustean case here had to make only one of these 2 decisions. One wasn't as important, but one of these decisions was absolutely key. It was fundamental to the success of the task. And we actually went back through the logs and we said, well, how did these developers do it manually? And we saw a case where a developer was going along, and he ran into this hard issue. And he said, oh, that looks hard. I'm going to come back to it later. Skipped over it and went on and kept doing these little manual fixes. And he never had time to go back to it in the first place. And that's why he failed at this task, right? What Procrustean really does more than any other thing, more even than all of this work that it saves, it helps you to really focus on what issues actually matter. What are the core barriers to this task being successful? And the reason why this is actually helpful is that when you press the go button, you see what these 2 errors that remain are. You can go and you can change your plan and press it again. You can see if one of them goes away. So you could try and modify your plan based on what's here. So it really supports this iterative refinement of your plans, because you can make changes because you're really focusing on high level, more impactful decisions than just, oh, this doesn't compile or this is not quite right, because these are all things that you can resolve yourself manually very quickly. Yeah.
So you're saying you would change your plan potentially if you saw one of these things was really hard. So the plan that you gave them, was that the plan after you had already done this and said, oh, no, I should do this plan instead?
It was a plan that was pretty much good. Yeah, so it was something that we'd already done. These are the right decisions. Like you shouldn't have to iterate on this anymore. This is actually after we had iterated on it to make them, as effective as possible. So if you were to do the task perfectly, you would probably have a very similar plan yourself. Okay, I realize I'm short on time. It's impossible to tell how much was used with questions, so I don't. Yeah, so I just want to talk just really very briefly about just looking forward, some things that I'm interested in the future. This will be very brief and then we'll be done, I promise. So looking forward, I think one thing that I am particularly interested in is looking at what information developers actually need. And this came out of this last project. So we had these assumptions that developers want to understand dependencies and they understand them in a graph. But it turns out that representing them in trees was just as effective for them. And a lot of work has gone into what questions developers have, but not what specific little fragments of information, what specific facts do they use to answer these questions. And I think understanding this key point of what these little fragments of information are is really of utmost value to tool developers, because we can say, well, if you want this fragment of information, we can generate it for you from this repository, from this resource. And to really highlight those pieces of information to developers, I think is really important. So from a basic research point of view, I think going forward from these questions and looking at how developers answer them and what specific information needs help them to answer them effectively, I think is really important. The second thing is developers have used the same editors to look at source code for quite a long time. So what I really want to look at as well is a more flexible means to actually perform this type of investigation. So instead of looking at a static view of the code, you can imagine that you want just a high-level view of what the code entails, because when we investigate source code, it's not always for the same reason. We're not always doing a code review. We're not always, and sometimes we're just doing a high-level, well, what affects the out parameters and return types of this method, right? So our needs aren't always the same, so why do we always provide the same editors? You can imagine having a slider where you can dial up or dial down the level of detail that a particular editor is showing you to help you more quickly be able to investigate source code. So that's another area that I think can really could really benefit from some future research in going forward. And this actually also came out of some interviews we had with some dev leads during my last internship here, where they were spending 70% of their time looking at code that other people wrote. And you know they don't need to look at every single detail there. They're just trying to get broad strokes in some cases. So how can we help these dev leads be more effective? The other thing is really improving developer awareness. So you can think of some type of code portal. So where you have this, here's your code portal. Here's the health of your system outlined in some sort of to use the terminology of Andy, like Facebook for developers, right? And you have this little mini feed. Here are the changes. So all of the little line items in this mini feed show you here's all of the things that are relevant for this code system. The problem is everything that's relevant for the whole system isn't what's relevant for me. I own a specific piece of code, and my code is dependent on specific other pieces of code. So why can't we just go through and help it so this feed shows me exactly the information I need? Like we can do an analysis and say, a quick analysis and say, I own these pieces of code. We can do that automatically. And we can say, my code is dependent upon these other pieces of code. And again, that's another automatic operation. So whenever some code that my code is dependent upon changes in a way that's significant, because we can analyze changes, for instance, if the API changes, we can say, look, here's a high priority piece of information for you to look at. So instead of showing all of the changes all of the time with all the priorities, we can say, show me only the changes that are relevant to me that have some high priority, so that are going to impact me in some way. So I think there's a lot of work that can be done here to really target annotation, target awareness events to help developers without overwhelming and alienating them. And just the last thing coming out of my internship when I was here. So we worked on this system called Deep IntelliSense. And if you're at TechFest, you might have seen it. It was well traveled. I think the 12th most visited booth, Andy said, out of 150. So a lot of people were there, and there's a lot of interest. And what Deep IntelliSense is really all about is providing developers information that they already have access to anyways, but in a format that's much more amenable to their needs. So instead of having to search through multiple silos to find context-relevant source code history information, we provide it to them automatically within the IDE. If you're investigating this method, here's how this method has changed in the past. Here are the other bugs that have been applied to this method. here are other emails that are involved in this method, or documents in SharePoint that reference it. And as you move through the system, it automatically updates this view. So instead of having you have to do these queries, the system shows it for you automatically. And I think one thing that's really interesting for this going forward, and this goes back to that basic information need that I mentioned earlier, is how do developers actually use deep intelligence? How do they use it to solve their daily tasks? What fragments of information in it are relevant for them? So I think that is a really interesting area going forward. And I guess in summary, I just want to say that the philosophy of all the work that I've done during my graduate career is that task specificity can really improve tool effectiveness. And on the screen, I have 4 specific tools where we've addressed a specific task and have shown some very real increases in developer productivity applied to those tasks. And I'd just like to say that through all of my experience, I found that really focusing on the developer's needs, the information they need, the tasks that they're doing, and providing tool support to actually help them can be very valuable and really has shown some real gains for developer productivity and effectiveness. And I'm happy to take any questions. I'm sorry for running long. Thank you.
So, since every one of you, I think, has an appointment with
That's right.
with Reed later, we can just save any further questions for the one-on-ones. So.
Thanks.